Okay, 20-1. This is one of the last videos that you'll be dealing with me over YouTube or anything like that, but I ultimately do think that it's nice that you maybe can go back and look at some stuff. So I hope yesterday factoring with just kind of a couple different quadratic functions looked okay to you. And then if you do have questions, you can ask me on Teams, you can message me, or you can send me an email, and I will be back on Tuesday because you have a long weekend, which is kind of nice. So yesterday you learned how to solve quadratic equations with the graphical approach. So again, when we're solving something, that's we're trying to find how many solutions it have or what are the factors that come to it. Okay, we learned previously that you can solve something with either finding if it's y1, y2, you have to find the point of intersection. Okay, so if there's 2 points, if you have both sides of the equation, or we said if there's solutions, okay, if it was just one equation and you had to, if you solved everything to one side is 0, and then you had to find the zeros to it. Okay, so this is kind of what we talked about. There's 3 options that can happen. It's either it doesn't cross 0 at all, okay, if we set it equal to 0 for finding the solutions of the x-intercepts. Okay, there's either one solution where it's our vertex, or there's 2 solutions where it crosses x at both times. Okay, so that was us solving it using our calculators, graphing it, telling me how many intersections there are, tell me how many points there's going to be, things like that. Today, because we've done with factoring a lot, we're going to break down of doing it without a calculator. We're going to move all the terms to one side, and then we're going to factor the polynomial. Okay, but there's a couple things that we want to start with first. If I have a times b is equal to 0, what can you deduce or what can you tell me about a and or b? Okay, well, if they're equal to 0, it means that one of them has to be equal to 0. So either a is equal to 0 or b is equal to 0. Okay, anything times 0 is 0. So as long as we know that, then we can kind of move forward. So we're going to determine the roots of each of the quadratic equations. So when I'm looking for the roots, I want to find the x-intercepts, and we're going to verify our solutions. So the first one is here. So I have x squared plus 6x plus 9. Okay, I need to factor the quadratic function that I have right here. X squared plus 6x plus 9. My a value is equal to 1, so I know that it should be my simple, what are 2 numbers that multiply to get to 9 and add to get to 6? I know it's going to be, okay, should be 3 and 3. So plus 3 plus 3. I'm going to say that is equal to 0. Okay, when I have 2 things that equal to 0, I can set them equal to 0 individually. Okay, x plus 3 equal to 0. I need to try to figure out, well, what is x equal to? How do I get x by itself in this equation? Well, I would subtract 3, cross it out, subtract 3. X is equal to negative 3. Perfect. If I were to do the other one, this one's the same equation. Okay, I know that x is equal to negative 3. So verify my solutions. Well, I know that there is an x-intercept. Therefore, I have an x-intercept at negative 3. Okay, is this one solution? Is this 2 solutions? Okay, I'm also used to seeing this here at x plus 3 squared. Okay, this is going to tell me that the vertex is at negative 3. You can verify it by either plugging it into your calculator and checking it out, or algebraically verifying. I'm going to plug negative 3 into my original equation. So anytime I see a negative 3, or anytime I see an x, I'm going to plug in negative 3 squared plus 6 times negative 3 plus 9. Here I get 9 minus 18 plus 9. Well, 9 plus 9 is 18 minus 18. That's equal to 0. Okay, I'm correct. Perfect. Okay, let's do another one. So here again, you always want to, if I have x squared plus 4x is equal to 21, we know graphically I can set y1 is equal to x squared plus 4x, y2, I can set it equal to 21, and I'd have to find the intersection point or points to see what this would equal to. Algebraically, I want to set this equation equal to 0. So I'm going to move that 21 over. So x squared plus 4x, I'm going to say minus 21 is all equal to 0. Okay, me looking at x squared plus 4x minus 21, factoring, okay, this is equals 1, 2 numbers that multiply to get to -1 and add to get to 4. I get x plus 7 and x minus 3. Those are my factors. That is equal to 0. So for you to find out, okay, well, how do I solve for where my x-intercepts are? Okay, if I set x plus 7 is equal to 0, I'd have to subtract the 7 on the one side, so I know that x is going to be equal at -7. If I set x minus 3 is equal to 0, and I solve for x to get by itself, I'd add 3 to both sides. So then here I get x is equal to +3. You kind of should be seeing a pattern that if it's a +7, x is at -7. If it's a -3, my x-intercept, my solution is going to be, if it's negative, it's going to be a positive. Perfect. Okay, let's flip to the next page. And we're going to solve each of these using that algebraic approach. Okay, so we're going to look here. So 2y squared is equal to 9y plus 5. So I always try to have my squared term as a positive. So here I'm going to move everything else over to the other side. So I'm going to have 2y squared. I'm going to subtract 9y, so minus 9y, minus 5 on this side crossed out, minus 5 on the side. I'm left with 0 on my right side, which is what I wanted. Okay, I need to factor 2y squared minus 9y minus 5. So my factoring pieces here, I know one of them has to be 2y, one of them has to be y. The factors of 5 are 1 and 5. So I'm going to go 2. This one's going to be a -5. This one's going to be a +1. Okay, that's all equal to 0. I have my factors here. And when I'm looking at my factoring, okay, well, I know at least one of them. My first one, well, this is y minus 5 is equal to 0. Okay, that means that y is +5. So y is equal to +5. That will make it equal to 0. And my other side, well, now I have two different pieces. So again, I want you to think of, okay, well, I'm going to set 2y plus 1 equal to 0, and I'm going to solve for y. -1, -1, divide by 2, divide by 2. My y is going to be equal to -1/2. And that's my other solution. Y is equal to -1/2. Okay, because again, when we're solving for x-intercepts, well, if we know our x-intercepts are at my zeros, if I'm multiplying two pieces, I know that at least one of them is 0, if not both of them. So that's why I have my two solutions. Okay. Let's do this one here. Our favorite thing, we have lovely fractions. Okay. The nice thing about fraction is that we want to get rid of the denominator. So I'm going to multiply, because what you do on one side of the equation, you're going to do to the other side. So I'm going to set everything equal to 0, which it already is. I want to get rid of these fractions. I'm going to multiply by the common denominator. Common denominator here is 2. So I'm going to multiply this whole side, or the whole equation, not whole side, whole equation by 2. Okay, 2 times m squared, so I get 2m squared. 2 times 5 over 2, so I'm going to get 5m plus 5m, and then plus 2 times 3 is 6 divided by 2 is 3, and then 0 times 2 is still 0. So this is the same equation here, but what I did on one side and the other side, it's the same. Now I see that I have 2m squared plus 5m plus 3. I need to factor this out. So I know one of them has to have a 2m. This one's going to have an m. Okay, my factors of 3 are 1 and 3. And I want to get to 5, so I know this one's going to be the plus 3. This one's going to be my plus 1. Okay, I need to solve each bracket to say if it was equal to 0. So I know that one of them, the m has to be -1. Because if m was -1, -1 plus 1 would equal 0. And then over here, I solve 2m plus 3 is equal to 0. So I know that m is going to be equal to -3 over 2. Oops. There we go. And if I were to plug that in, 2 times -3 over 2 plus 3, that would give me 0. So these are my solutions to this piece. Okay, let's do 2 more, and then I'm going to do a word problem with you. So you have 8b squared minus 18b is equal to 0. So you've always been taught with factoring, you always take out the greatest common factor first. That's the first thing you're going to do here as well. It's all equal to 0, so the greatest common factor on this side is a 2, and then there's a b on both of them. See what I have left. So I have 4b minus 9 is equal to 0. I can't factor this anymore, but when I'm broken down to, these are my 2 factors. One of my factors is 2b. The other factor is 4b minus 9. Those are both equal to 0, so I need to figure out, well, what are the solutions here? What does b have to equal for both of these pieces? Well, I know the 4b minus 9. If I set that equal to 0, I have to add 9 on both sides and then divide by 4. So this is going to be a positive 9 over 4. And that's one of them. The second one, I have to think, well, what is going to make this factor piece equal to 0? Okay, well, it's just 2 times b. So what does b have to be to make it equal to 0? And for this one, it is going to be 0. 2 times 0 is equal to 0. So my solutions for this one, anytime it is just a number times your variable, your 0 is going to be at 0. Perfect. Okay, so that one was nice and easy. Let's do this one. First thing I'm always going to do is check if there's a greatest common factor. There is for this one. I'm going to take out a 2. I have left x squared minus 10x plus 25. That's all equal to 0. Because we're all so good at completing the square, we notice that this is my perfect trinomial. Okay, so I know that I can split this up right away as x minus 5 all squared. And that is equal to 0. So to set my one piece, so my one bracket here equal to 0, I know that my bracket, the x has to be equal to a positive 5. Because 5 minus 5 is 0. 0 squared is still 0. Although those 2, I did take this 2 out, it is a bracket, there is no x involved in that. So there isn't another intersection or another 0 at that point. It is just going to be x is equal to 5. Okay, so you're going to pause this video here. I want you to try the your turns, and then I'll just write the answers down. And my last example is just going to be with, again, our lovely area rectangle tables, and then I'll be done. So you can pause here, and here are the answers. So your first one is a difference of squares. So you should have had x minus 4 and x plus 4. So your x's therefore are going to be x is equal to 4 and x is equal to negative 4 to account for both of those. Okay, this one over here, you make sure that you have to subtract the 2b, subtract that 8 to get it all equal to 0. So it was 3b squared minus 2b minus 8. To factor that out, your factors came out to be 3b plus 4 and b minus 2 equals to 0. Therefore, my solutions, or my zeros, was, that didn't make sense, negative 4 over 3, and b is equal to positive 2. Awesome. Okay, last example that I'm going to do with you, this one here. So the area of a rectangular ping pong table, it is 45 square feet. The length is 4 feet more than the width. That's going to be a super important sentence. The length is 4 feet more than the width. What are the dimensions of the table? Set up an equation and solve. This is supposed to be set up an equation, not and an equation. Okay, set up an equation and then solve. So I'm going to, well, I know that my area, or we all should know that area is equal to length times width. Okay, again, we can't have two variables in our equations. We need to all break it down to another set. So I'm going to say, well, my width is going to be equal to W, and then my length has to be in terms of W. I don't have how much my perimeter was or anything like that, but I was given this highlighted piece. The length is 4 feet more than the width. Okay, that means that I have the width plus 4 more feet, and that's going to be what my length is. Okay, so I have my two different pieces here. Now, if I know area is length times width, well, my length came out to be width plus 4, and my width is just W, and I know my area was given to be 45 feet. I'm going to multiply or expand these two out, so I get 45 is equal to W squared plus 4W. And I want to solve algebraically, so I need to solve this. So I need to figure out, well, what are my zeros or what are my solutions? So I'm going to set this whole equation now equal to 0. So I'm going to minus the 45, minus the 45. My new equation comes out to be W squared plus 4W minus 45. That's all equal to 0. That's equal to 0. I'm going to factor this equation. Okay, it has a coefficient on the first term of 1. So two numbers I'll multiply to get to negative 45 and add to get to positive 4. So I get 9 and negative 5. So I had W plus 9 and W minus 5. That's all equal to 0. So what are my solutions here? Okay, so my solutions come out to be W is equal to a negative 9, and W comes out to be a positive 5. So these are my solutions. When you're thinking about your solutions, though, you need to start and think, okay, can I have a negative dimension? So it's saying that your width can be negative 9. Can I have a negative dimension? No. Okay, you can't have that negative dimension. So negative 9 is not a solution for this setup. Yes, it's a factor of this parabola, okay, but it cannot be a solution for this setup. So that means that W being plus 5, that is going to be one of my solutions. My question is actually asking what are the dimensions of the table. So I know that my width is 5. Okay, the dimension is going to be 5 times, and then my length is W plus 4. If my width is 5, going to be 5 plus 4. So 5 times 9 feet by feet. These are the dimensions of the table. Okay, so that was a lot of work. Okay, I'm going to write out some homework here, some homework questions here for you to take out your textbook and work through these pieces. Okay, your homework is page 230 to 232. We're going to go numbers 8, 9, A, B, E, 10, 11, 17, 20, and 22. Okay, so these are the questions that you're working on your textbook. Again, if you have questions, please message or email me on Teams. I will be back on Tuesday, and